All right, so this is the retake assignment to be able to retake the tests for sections 4.2 to 4.4. In this first problem, they're asking us to basically analyze the rational function and to graph. So we have some steps here that we need to follow to analyze. First thing we need to do is factor. And this would be x minus 5 and x plus 2 over x plus 2 and x minus 2. And first thing we need to do is identify the domain, and the domain is all real numbers except for the numbers that make the denominator 0, which is positive 2. X cannot equal positive 2, and it cannot equal negative 2. Whoops. So these are the values in our domain. They're either going to be a vertical asymptote or a hole, and because we have factors of an x plus 2 on top and on bottom, x plus 2, or the factor of the 0 of minus 2 is going to be a hole, and this one is going to be a vertical asymptote. So I'm going to draw those on here. So I have x plus 2 is a vertical asymptote, and I have a hole at x minus 2, and I'm just going to draw that in there. It's not necessarily on the x-axis, but it's going to be wherever the graph has an x value of 2, and we'll look at that when we do the graph. Next thing we need to do is find our x-intercepts. So the x-intercepts come from the zeros in the numerator. So I'm looking at the zeros in the numerator up here, so that would be x equals 5 and x equals negative 2. Now remember, we have that hole at negative 2, so it's not necessarily going to be an x-intercept. But I do have an x-intercept at 5. I'm going to draw that in here. Now to find the y-intercepts, I'm going to set x equal to 0, as always when we're finding a y-intercept. Now I can go back here and plug in zeros into all my factors, but generally when I'm doing x-intercepts, if I go back to the original equation, anywhere I see an x is 0, so I'm really left with just this part right here, which is negative 10 over negative 4, which is 10 over 4 positive 2.5. All right, and that's on our y-axis. So I'm just going to label that 2.5. Now I need to determine if I have a horizontal asymptote or a slant asymptote. Comparing my numerator and denominator powers of x, the degrees, my numerator is degree 2 and my denominator is degree 2, and they're equal. And when that happens, I do have a horizontal asymptote, and that occurs at the coefficients. And I just have coefficients of 1 over 1, which is a horizontal asymptote at y equals 1. So I'm going to draw that in here. Now I need to decide where my graph is positive and negative. And to do that, I'm going to put on the important parts of x. All right, so I'm going to put in here, it won't hurt if we put in negative 2, because that was an x-intercept. Let's see what happens on both sides of that. And then I have a positive 2 and a positive 5. So we're looking to see what happens on each side as the graph is approaching these values. So at negative 2, let's think of number less than negative 2, so how about x is negative 3? And if I go in and I plug in -3 here, -3 minus 5 is negative, plus 2 is negative, over -3 plus 2 is negative, and x minus 2, -3 minus 2 is negative. Really, what I need to check is x minus 5 over x minus 2, because these will end up canceling themselves. Okay, so really, x minus 5, that would be negative over negative, so that's positive. So that section right here is positive. At 0, and I'm looking between -2 and 2, at 0, I know I have a y-intercept at 2.5, and that's positive. So at 0, I'm going to have a positive value. So anything between -2 and -2 is positive. How about +2 to 5? So let's choose 4. If I plug in 4, 4 minus 5 is negative, and 4 minus 2 is positive. So this section is negative. And beyond 5, like 7, I have 7 minus 5 is positive over 7 minus 2 is positive. So this is positive. So now I'm looking at what is happening on my graph. So I know that from -2 going through my intercept all the way up to +2, I'm going to have positive values. So I'm going to draw that in here. So I'm going to have positive values going up to the y-intercept and drawing that through. And again, it can't cross the vertical asymptote. So that's what we have here. Also noting that I do have that hole at 2, so I'm just going to draw that hole in the graph. Okay, there is no x value of 2, and if you look at Desmos, they won't show you that on Desmos. Now this other part to the right of 2, I have a negative and then a positive, and I know that it changes at the x-intercept. So I'm just going to draw that to this side of 5, it's negative, and to this side of 5, it is positive. So there's the graph for that one. Number 2, I need to factor. So I have a -x on top, and on the denominator, I have an x minus 5 and an x plus 4. My domain is x cannot equal 5 and x cannot equal -4. And because neither one of them have a factor at the top, both of these are going to be vertical asymptotes. So I am going to draw those in. Here's 1, 2, 3, 4, 5. I'm going to have a vertical asymptote here at 5 and at -4. You see that there. Then I'm going to check for x-intercepts, and that's where the numerator equals 0, and that happens at 0. So the x-intercept is 0. If I draw that on here, I have the point 0, 0. So x-intercept is 0, so is the y-intercept, because it goes through the origin. Now I'm going to look for horizontal asymptotes or slant asymptotes. Comparing my numerators, my numerator is degree 1, my denominator is degree 2, so the denominator is bigger. When that happens, I do have a horizontal asymptote, and it is at y equals 0. and that would be the x-axis. Okay, so we have a horizontal asymptote here. All right, so now looking at where is my graph positive or negative. So I'm going to do my number line. How about if I do that space where I can draw and see as I calculate. So on my x-axis, these are my points of concern on my number line. So I have one at -4, I have one at 0, and I have one at 5. All right, so to the left of -4, if x equals -5. When I put that into my equation, the opposite of -5 is +5. -5 minus 5 is negative, and +4 is negative. So the two negatives on bottom make it positive. So I have a positive value left of -4. Between 0 and -4, like -1. The opposite of -1 is +1. -1 minus 5 is -6, and -1 plus 4 is positive. So one negative here means this is negative. Between 0 and 5, like x equals +1. Now the opposite of 1 is negative. 1 minus 5 is also negative, and 1 plus 4 is positive. Now the two negatives here make this section positive. And now the last section, something bigger than 5, let's do x is 7. The opposite of 7 is -7. 7 minus 5 is positive, and 7 plus 4 is positive, so this is negative. All right, so now I'm going to build the graph. So if I look here, I've got sections. To the left of -4, and this area has to be all positive. So as I am going towards -infinity, it's approaching that asymptote, and as I get closer to -4, it's approaching the vertical asymptote. Now I have this x-intercept, and it says to the left it's negative, and to the right it's positive. So this is going to come down and go this way, while this is going to come up and go this way. And this last section to the right of 5 has to be all negative, so we have a part in this section. On number 3, this one was a little bit harder than I thought, but we're going to do it anyway. I have factors here of x plus 4 and x minus 3 over x minus 5. So here, my domain, x cannot equal 5, and I would have a vertical asymptote there. So on my graph, let's draw that. 1, 2, 3, 4, 5, vertical asymptote here. I have x-intercepts at x is -4 and x equals 3. So at -4 I have an x-intercept, -5, and whoops, that's not right. At x equals +3, this is the positive side, I have a x-intercept, and at -4. All right, so then I'm looking for the y-intercepts. Okay, remember x is 0, so if I look at this part, this area right here, -12 over 5, that's -5. So this is going to be positive 2 2/5 or 12/5. But if I just put that on my graph, it's going to be about in here. So that's my y-intercepts, 2 2/5. Now I need to check for horizontal or slant asymptotes. My numerator is 2, my denominator is 1. Numerator is bigger by 1, so this is where I'm going to do my synthetic division, and I'm going to do that up here. So I'm going to take x minus 5 and divide that into x squared plus x minus 12. Multiply x by x squared here. This is x squared minus 5x. When I subtract, I have 1x minus negative 5, so that's plus 6x. Now I say x multiplied by 6 plus 6, and then I'm going to get 6x minus 30. I don't care what the remainder is. That's going to be the remainder. This is the equation of the slant asymptote. All right, so 1, 2, 3, 4, 5, 6. So this is looking like this. And this comes up here like this. All right, so now I am going to see where is my graph positive or negative. So here's my number line. The values of x, I have a -4, I have a 3, I have a -5, or x equals 5, this is positive. And that's all I got on the x-axis that's important. Remember, a graph can cross through a horizontal or a slant asymptote, but never a vertical asymptote. So this one, if I pick numbers less than -4, okay, now remember I'm checking into these factors. So I have, let's say x is -5. -5 plus 4 is -1. -5 minus 3 is negative. -5 minus 5 is -10. So 3 negatives make this negative. Between 4 and 3, this is where my y-intercept is. So I know that if I have a y-intercept that's positive in between here, all of this is going to be positive in here. Then between 3 and 5, let's check x equals 4. 4 plus 4 is 8, that's positive. 4 minus 3 is 1, so 4 minus 5 is -1. So this is negative in between 3 and 5. And then after 5, let's try x equals 6. Okay, or anything bigger than 5. 6 plus 4 is 10, that's positive. 6 minus 3 is positive, and 6 minus 5 is +1, so this is positive. All right, so looking at the graph inside here, at my x-intercept, to the left of -4 is negative, and to the right of that it's positive. Okay, now looking at x is 3. To the left of 3 is positive. This one I was saying is a little difficult. Between 3 and 5 is negative. So this is going to come down here. This is going to come down this way. And at some point, these are going to curve back around. Now, it does have to go, both of these, through the y-intercept. So I think that's going to be kind of like a maximum value here. That's where it's going to change direction and turn back around. Then after 5, to the right of 5, I'm going to have all positive values. Now, if I have something here that's approaching my asymptote, it's eventually going to go negative. So I need to keep that all positive, and I can do something like this. Okay, so that was a little bit tricky in here, and I think that was a little more difficult than I intended it to be. But there it is. On solving the inequalities, we're looking basically at the number lines. We don't have to make the graph. We just need to know where is it positive or negative, and looking at the sign. What are we looking for, positives or negatives? So my domain here is all real numbers, and my x-intercepts are at 0 and at 1 and at -4. So on my number line, I didn't want to make it that big, I have -4 and then 0 and then 1. Okay, so I'm going to actually do some drawing over on this side, calculating. So if I pick a number less than -4, I'm plugging them back into these factors. So how about I choose x is -5? Okay, so these are my intercepts. Now I'm just calculating. If I put in -5 for x, that's negative. -5 minus 1 is -6, and -5 plus 4 is -1. So this is negative. If I choose x is something between 0 and -4, let's try -1. -1 for x is negative. -1 minus 1 is -2, and -1 plus 4 is +3. So the two negatives here and the positive make this section positive. Between 0 and 1, let's say I have x equals 1/2. 1/2 is positive, so just in for x, that's positive. 1/2 minus 1 is negative, and 1/2 plus 4 is positive. This section is negative. And to the right of 1, let's say x equals 6. Go far right of 1. I have x is 6 is positive, 6 minus 1 is positive, and positive. So my sign here is the y values have to be less than 0. That means this is negative, and it does not equal our zeros. So I don't have values that it can equal the values I put on here. So if I'm looking for negatives, I have numbers less than -4 and numbers between 0 and 1. And I'll write my set notation, interval notation, where I'm starting at -infinity. I make it to -4, not including -4. And then I'm going to union that with the set of numbers between 0 and 1. All right, so that is the solution set. The next one, oh, it's nice, it's factored for us. Here I'm looking for numbers that are positive, and they can equal this time. If I check my domain, I cannot have an x equals 4. All right, on my number line, I would have a vertical asymptote at x is 4. My x-intercepts are at -2 and +6. So I have -2, 4, and 6 are my numbers to be concerned with on the number line. So I'm going to plug in values for each region now. Number less than -2, how about -4? If x is -4, -4 plus 2 is negative, -6 is negative, and -4 minus 4 is negative, so this is negative. Between -2 and 4, how about x is 0? If I have 0 in here, that's positive 2, then negative 6, and then negative 4 on bottom. This is positive. 2 negatives make the positive. Between 4 and 6, I'm going to pick 5. If x is 5, 5 plus 2 is positive, 5 minus 6 is negative, 5 minus 4 is positive, this is positive. And lastly, a number bigger than 6, how about 7? 7 plus 2 is positive, 7 minus 6 is positive, and 7 minus 4 is positive. So this section is positive. Oops, that last one should be negative, sorry. All right, so I'm looking for positive values. Now, I need to remember my x-intercepts are negative 2 and 6, and I can equal those values because there's an equal sign here. So at negative 2 and 6, I'm going to equal, or I can include those in my sets, but I cannot at 4 because there's a vertical asymptote going through here. So I can never include a value of 4 because that's not in my domain. So I'm looking for positive values. So I have a positive here and a positive over here. And to write the set notation, I have numbers between and including negative 2 up to 4, not including 4, and another set, whoops, at 6 going to infinity. And lastly, number 6, I'm just looking at the graph. I see here at negative 1 and at positive 1, I have vertical asymptotes going through those, so that must mean that those values cannot be included in the domain. So I'm going to say for all values of x, x cannot equal positive or negative 1. Also, down on part D, I can write the equations for those vertical asymptotes at x equals 1 and x equals negative 1. I also have an x-intercept here at 0, so this is the point 0, 0, which is also my y-intercept. And it looks like my horizontal asymptote, I think I have one here. This branch is closely approaching the x-axis, and same on this side. So I'm going to say that my horizontal asymptote is y equals 0. That's the x-axis. All right, we should be all set now.